Here's the hidden pattern behind these kind of math problems that I'll show you today.
Always a good idea whenever possible to have the x and the y directions labeled. That way we can have common language. He's going to make this cut, and we want this perimeter.
That's today on High Peak Education.
Here we go, number 5. Kayaking. It says a kayaker is traveling across a river at a velocity of 5 kilometers per hour. If the current is traveling at a rate of 2 kilometers per hour in a direction perpendicular to the kayaker's movement, what is the actual speed of the kayaker to the nearest hundredth? So let's imagine we have this river here. So this is the bounds of the river. Always a good idea whenever possible to have the x and the y directions labeled. That way we can have common language. So x would be to the right, and then upward would be what?
Y.
And we're told that the kayaker is trying to cross the river. So traveling across the river at a velocity of 5 kilometers per hour. Given that we're told how fast and which way, is this going to be a scalar or a vector?
Vector.
I think it's going to be a vector. So we should kind of have it like so, right? And why don't we call this V subscript push? Now, we could call it V subscript rho, R-O-W, but the idea is that that could get confused with V subscript R, which might be like river, right? By the way, I like to make things positive, right, in terms of positive X and positive Y. If the push is in the positive Y direction, what direction might we want to make the river going in? From the left to the right, okay, like that. Now notice, do we want to make the length of the vector of the velocity of the river as long as the push velocity or smaller? Yes, why smaller?
Well, it's because it's, I guess, just going at a slower speed.
Yeah, exactly. It's 2 kilometers per hour. It's slower speed. So let us label this as, let's call it vector of the river. By the way, you could also do subscript R. Now what we're looking for is what is the actual speed of the kayaker to the nearest hundredth. So whenever we add two velocity vectors, we get a what?
Well, don't you just get a, well, I don't know how to say hypotenuse, but I mean, it's just the sum.
Yeah, it's going to be the vector sum. And let's have a think about this. If it's the sum, the vector sum, do we add them just like we add two vectors together like we've done earlier in this course? So would it be like this? So let's call this vector VK, K for kayaker. So yes, you are indeed correct. It's essentially going to be the hypotenuse of a right triangle. You see that? Because indeed they are perpendicular to one another. So let us simplify this problem down to a right triangle that corresponds to what's going on here. So I think that, let's see, this side would be 5 kilometers per hour. The river is, 2 kilometers per hour?
Yeah.
So you're right, we need to find the hypotenuse. So which theorem we're going to use?
Pythagorean.
Yes, so let's write this down. Use the Pythagorean Theorem as the resulting kayaker speed is the hypotenuse of a right triangle. So with that established, I think we're in good shape. So let's go, 5 squared plus 2 squared, and take the what?
Square root.
Yeah, so I think it's going to be the square root of 5 squared plus 2 squared. Yes, indeed. So that's square root of 29. Okay, so square root of 29. Now we're told to get it to the nearest tenth. So in this case, are we going to do an approximate? Yeah, in this case, we're going to do an approximate. So I'm going to reach for my calculator here, and then I'm just going to type in the square root of 29. 5.39, yeah, to the nearest hundredth. Good job. And what would the units be? Nicely done, kilometers per hour. And I think that'd be our final answer. Any questions about how we got that? All right.
Hey, thanks for watching our content here in High Peak Education. Please hit those comments down below this video and let us know what other kinds of videos do you want us to make. Thanks for your engagement. We appreciate it. Let's get back to today's video.
Let's move it along. 11, baking. Warren must cut a carrot cake in half that is the shape of a wide cylinder for a catered event. If the cake is 5 inches tall with a diameter of 12 inches and he cuts along the diameter, what is the perimeter of the cross section? So it's going to be like this, very wide compared to how tall it is. Okay, so I think the height is 5 inches and then the diameter is 12 inches. And he cuts along the diameter. What is the perimeter of the cross section? The idea is this. the perimeter of what he's going to cut. So let's imagine he's going to make this cut, and we want this perimeter. He cuts along the diameter. What's the perimeter of the cross section? So I think it's what's shown in red, right?
Right.
So if you think about it, it's the diameter plus half the what? What's the C word around the edge of the circle?
Circumference.
Right, half the circumference.
Yeah.
So let's get that in terms of an equation. The perimeter would equal the diameter, which we have, plus, what would half the circumference of a circle be?
Pi r.
Exactly right. Diameter and half the circumference. So the diameter plus pi r. Okay, and I think we have enough information to calculate that, right? And so it's pi times 6. So often we just write that as 6 pi, right? So this would be 12 plus 6 pi, and that's going to be units of what? So this is the exact value. Now, do they ask for it in tenths or hundredths of an inch?
No.
I'd just leave it as exact.